The USA has been digging under cities with its colossal machine, Bertha, for years. This massive drill has tunneled beneath skyscrapers like it is slicing through butter. But now, after finishing that job, America has unleashed a new secret machine that can drill through mountains in just one day. What are they building now, and why is it such a big secret? Bertha did some great work, no doubt, but let's not forget the project was not smooth sailing. There were controversies, delays, and even some accidents. Is that why this new project is still kept a secret? What exactly is this new machine, and what are they planning to do with it? Let's find out. The Ash Wednesday Incident. In the early hours of February 28, 2001, Seattle was shaken by a 6.8 magnitude earthquake. This earthquake struck the city and left behind a wake of destruction. Buildings swayed, roads cracked, and the iconic Alaskan Way Viaduct, which was a major thoroughfare running through downtown Seattle, was severely damaged. The incident was named the Ash Wednesday Incident. The quake lasted only 45 seconds, but the aftermath revealed just how vulnerable the city's infrastructure was. The viaduct, which was already aging and worn, was now a ticking time bomb. Engineers estimated that another major quake could bring it down entirely, putting lives and the city's economy at risk. The problem was big, really big. The viaduct carried about 110,000 vehicles daily, and shutting it down would choke Seattle's traffic flow. Repairing or replacing the structure above ground seemed impossible without causing years of traffic nightmares. Something drastic had to be done. The city needed a solution that could bypass the surface chaos altogether. This was when the idea of tunneling beneath the city was born. But drilling a tunnel underneath a busy metropolis was not going to be easy. Engineers and city planners started brainstorming. They needed something that could dig through the earth quickly and safely while causing minimal disruption above ground. What solution did they come up with? They decided to build a giant tunnel boring machine, or TBM, unlike any other before it. This machine would need to be enormous, precise, and powerful enough to handle Seattle's unique soil conditions, which range from loose sand to hard clay. This was when Bertha was introduced. Named after Bertha Knight Lands, Seattle's first female mayor, this TBM was a giant machine that was designed to chew through Seattle's underground terrain. They decided to design this giant machine because the Ash Wednesday incident had shown that the city's existing infrastructure was vulnerable, and simply patching things up was not enough. A tunnel provided a long-term solution that could withstand future quakes and modernize the city's transportation network. But building such a tunnel required cutting-edge technology, which led to the creation of Bertha. Before we have a look at what Bertha is and how she was created, here's a question for you. Do you know how tunnel boring machines work? How tunnel boring machines work? Tunnel boring machines, or TBMs, do exactly what their name says they do. These machines are designed to dig tunnels deep underground without causing much disturbance above ground. You can imagine them as giant moles, but way more high-tech. Let's start with the basics. A TBM is a massive machine, sometimes as long as a football field. The front part is called the cutter head, which is a huge rotating disc covered in sharp tools. When this cutter head spins, it chews through the earth, breaking up everything in its path, whether it is rock, soil, you name it. The debris or muck is then moved out of the way by conveyor belts or a slurry system. This keeps the tunnel clear so the TBM can keep moving forward without stopping. But TBMs don't just dig, they can also build as they go. Behind the cutter head, the machine installs concrete segments that form the tunnel walls. These segments are shaped like giant curved puzzle pieces and fit together perfectly to create a strong, stable lining. The machine has a system that places these segments in just the right spot, securing them with bolts and grout. This is what makes the tunnel sturdy and prevents the ground from caving in behind the machine. Now, steering a TBM is no easy task. You cannot exactly turn a giant drill with a steering wheel, right? Instead, TBMs are guided by lasers and GPS. Engineers program the machine with a precise path, and it adjusts its direction using hydraulic cylinders that push against the tunnel walls. This process makes sure that the tunnel stays on track, even when it has to curve or go deeper underground. TBMs also have to deal with all sorts of ground conditions, Sometimes they cut through soft soil, other times they grind through hard rock, and occasionally they even hit water. To handle these different conditions, some TBMs have a pressurized chamber behind the cutter head. This chamber balances the pressure between the tunnel face and the surrounding ground, which helps prevent collapses or flooding. To imagine how big tunnel boring machines can be, know that the largest TBMs can have cutter heads over 60 feet wide. That's big enough to fit a 4-story building inside. Despite their size, these machines are incredibly precise. They can tunnel within inches of existing buildings without causing damage, which is pretty mind-blowing. So we had all this technology, all we had to do was build Bertha. So how was this tunnel boring machine different from the others? What's Bertha? Bertha was different from others because it was the largest tunnel boring machine ever built at the time. Standing at 57.5 feet in diameter and stretching 326 feet in length, Bertha weighed a staggering 7,000 tons. It was designed by Hitachi Zosen Corporation in Japan, and she was built specifically for Seattle's Alaskan Way Viaduct replacement project. The goal was to dig a 1.7-mile tunnel beneath downtown Seattle to create a new underground highway and replace the aging, earthquake-damaged viaduct above. Once built, Bertha was like a self-contained tunneling factory. At the front, her massive cutter head could exert up to 25 million pounds of pressure, rotating at a speed of 1 to 2 revolutions per minute. The cutter head was fitted with 260 cutting tools, designed to chew through Seattle's varied soils, from soft clays to hard glacial deposits. Behind the cutter head, a series of conveyor belts transported the excavated material out of the tunnel. As Bertha dug forward, she also installed the tunnel's lining, placing curved concrete segments into position, one after another. This automated system ensured that the tunnel was stable and strong, even as Bertha inched forward. The design of Bertha was incredibly intricate. Her cutter head exerted brute force, yes, but it also did it with high precision. The cutter head was divided into multiple sections, each designed to handle different types of soil. This allowed Bertha to adapt as she moved, adjusting her speed and cutting pressure based on the ground she encountered. The machine was also equipped with sensors that monitored her position, ensuring she stayed on the planned path. Engineers could control her movements down to the inch. They would use the monitors to guide her as she curved and descended beneath the city. On July 30, 2013, Bertha began her excavation journey. The start was smooth. She moved forward at a steady pace, making progress. But then, in December 2013, just 1,000 feet into the dig, disaster struck. Bertha's cutter head hit an unexpected obstacle. It was a steel pipe left behind by a previous project. The impact severely damaged the cutter head, and it ground the entire operation to a halt. What was supposed to be a quick project turned into a 2-year nightmare. The damage to the cutter head was extensive. Bertha was stuck, unable to move forward, and repairs were complicated by the fact that she was trapped underground. Engineers had to come up with a solution, and fast. The first step was to build a 120-foot deep access shaft in front of Bertha, allowing workers to reach the damaged cutter head. Once the shaft was completed, crews began the painstaking process of disassembling and removing the broken parts. They did not have to just replace the damaged cutters, they also had to reinforce Bertha's entire front end to prevent future breakdowns. While the repairs were underway, the project faced public scrutiny. The delay added millions to the cost, and some questioned whether the project would ever be completed. But the engineers pressed on as they were determined to get Bertha back on track. After nearly 2 years of repairs, Bertha was finally ready to resume her journey. The damaged parts had been replaced, the cutter head reinforced, and the machine was tested rigorously to make sure everything was in working order. On December 22, 2015, Bertha roared back to life. The giant machine, once stuck and broken, was now back in action, ready to finish what she had started. So did it complete the task for what she was made for? The end of Bertha. When Bertha resumed tunneling under Seattle after nearly 2 years of repairs, things seemed to be going smoothly for a while, but then another problem halted the project. In January 2016, a sinkhole appeared near the tunnel site, and not just any small sinkhole. This one was 35 feet wide. It was a serious situation, and it stopped the project in its tracks once again. The sinkhole was caused by the muck. The muck was not being removed fast enough, so it piled up and created a gap that caused the ground above to cave in. Engineers had to figure out how to fix this mess quickly before things got worse. To solve the problem, the team made some adjustments to how Bertha was operating. They fine-tuned the tunneling process to ensure the muck was cleared out more efficiently, which helped keep the ground stable. They also put extra safety measures in place, keeping a close eye on the ground above to catch any signs of trouble early. After sorting things out, Bertha was back on track. Finally, on April 4, 2017, Bertha completed her long journey. She had dug a 9,270-foot tunnel under Seattle, clearing the way for a new underground highway. The project had its share of headaches. There were delays, technical problems, and even a massive sinkhole. But in the end, it was a success. After all that hard work, Bertha's job was done. The machine was taken apart and removed piece by piece. Some parts were recycled, while others were put on display as a reminder of the incredible feat she accomplished. But just when everyone thought the story was over, a new mystery started right then and there. Rumor has it that there might be another giant machine hidden away, working on something top secret. So what's this new secret machine? Why has the US kept it secret? The next giant. The story of Bertha might have ended, but the story of another colossal machine had begun long before everyone knew. This new machine was Chessie. While Bertha made headlines, Chessie was quietly being prepared for a mission so secretive that even its existence was not revealed for years. So what exactly is Chessie? Chessie is a tunnel boring machine, much like Bertha, but with advanced technology. Named after the Chesapeake Bay region, where her journey began, Chessie was designed to tackle an even bigger challenge. It was constructing tunnels beneath the water, specifically beneath the Chesapeake Bay. The project, known as the Chesapeake Bay Bridge Tunnel Expansion, required something more advanced, more powerful, and definitely more secretive than Bertha. Chessie was built to dig a new two-lane tunnel parallel to the existing ones. The main aim here was to ease traffic congestion and improve safety for one of the most important routes on the East Coast. The need for Chessie appeared in the early 2010s, as the CBBT had become increasingly overwhelmed by traffic. The original bridge tunnel system, which was completed in 1964, was a marvel of its time. But by the 21st century, it was clear that an upgrade was needed. The decision to create Chessie was made in 2014, but details were kept tightly controlled. Why the secrecy? Simple. The CBBT is a critical infrastructure point, and any disruption or potential threat to the project could have serious consequences for transportation and security. Given the importance of the route, the decision was made to keep Chessie secret until the time was right. But secrets don't stay hidden forever. The existence of Chessie was finally revealed in 2016, but not by the government or any official agency. Instead, it was uncovered by investigative journalists who noticed unusual activity near the Chesapeake Bay. Reports of strange shipments, increased security, and a series of permits for underwater construction led to the discovery. It didn't take long for the pieces to come together. Chessie was the code name for a new TBM, and the project was the CBBT expansion. When the news broke, the world got its first glimpse of Chessie. She was smaller than Bertha, with a cutter head diameter of about 42 feet, but she was no less impressive. Chessie was designed to dig through the sandy, muddy soils beneath the bay, a task far more challenging than the dense, varied soils Bertha faced in Seattle. Chessie's mission was to create a tunnel that could handle the heavy traffic of the East Coast while remaining stable under the weight and pressure of the Chesapeake Bay above. The secrecy surrounding Chessie was also about security. The CBBT is a vital link in the U.S. transportation network as it connects Virginia's eastern shore with the mainland. Any threat to its stability could disrupt traffic for millions of people and impact the region's economy. So by keeping Chessie's existence a secret, the planners hoped to avoid drawing unwanted attention to a project that could be a tempting target for those with ill intentions. Chessie's work began in 2017, and by mid-2019 she had successfully completed her tunnel. The project, which cost over $756 million, was a success, providing a safer and more efficient route across the Chesapeake Bay. After it completed its task, Chessie herself was dismantled and removed, much like Bertha. But just when it seemed like the mystery of Chessie was solved, rumors began to swirl about yet another secret machine. Are there any other mega construction machines that most people don't know about? Other mega construction machines. When it comes to mega construction machines, Bertha and Chessie are not the only giants out there. Around the world, some truly colossal machines have been built to tackle the toughest jobs on the planet. These machines are so massive that they almost defy imagination. Let's take a look at some of the most notable ones. First, we have the BAZ 75710, the world's largest dump truck. This machine was built in Belarus by BelAZ and was designed to carry loads of up to 450 tons. That's about as heavy as 75 elephants. The BAZ 75710 is used in mining operations in Russia, where it hauls massive amounts of earth and ore from the pits to processing plants. With its 8 wheels, each 13 feet in diameter, and a powerful 4,600 horsepower engine, this truck is a vital piece of equipment in the mining industry. After that, we have the L2350, the world's largest wheel loader. It was manufactured by the American company Letourneau. This giant machine is also used mainly in mining. It can lift 72 tons in one go, which is roughly equivalent to lifting 12 fully grown African elephants. This monster machine is found in mining operations across the globe, from Australia to North America. Its massive bucket can hold up to 40 cubic meters of material, making quick work of moving earth, rocks, and minerals. We also have Caterpillar 6090, which is the largest hydraulic mining shovel in the world. This machine was built to handle the toughest digging jobs, capable of moving up to 100 tons of material with a single scoop. This machine is used primarily in large-scale mining operations and for extracting valuable resources from the earth. It can be found in places like Australia, Canada, and South America, where it helps mining companies extract everything from coal to iron ore. Now let's talk about the LR13000, the most powerful crawler crane ever built. This machine was made by Liebherr in Germany and designed to lift heavy loads to incredible heights. It has a maximum lifting capacity of 3,000 tons and can reach a height of over 820 feet, with its boom fully extended. The LR13000 is used in major construction projects, including building power plants, refineries, and other large industrial structures. No discussion of mega machines is complete without mentioning Big Muskie. This massive dragline excavator was once the largest machine of its kind in the world. This machine was built by Bucharest Erie in the 1960s. It was used to remove overburden, like the soil and rock covering a coal seam in southeastern Ohio. Weighing in at 13,500 tons, Big Muskie could move 39 million pounds of earth with each pass. Although it was retired in 1991 and later dismantled, Big Muskie remains a legend in the world of heavy machinery. Now let's have a look at the Komatsu D575A3. It is the world's largest bulldozer, and it is a beast. Built by the Japanese company Komatsu, this dozer is used in mining and heavy construction projects. It is capable of moving 90 cubic yards of material in a single pass, making it perfect for leveling large areas quickly. The D575A3 is primarily found in large-scale mining operations in the United States, Canada, and Australia, where it helps shape the landscape with ease. Finally, we have the Bagger 288, the world's largest land vehicle. This machine is a bucket wheel excavator used in open-pit mining. This monster machine stands 315 feet tall, is 738 feet long, and weighs 13,500 tons. It can move 240,000 cubic meters of material every day. Bagger 2808 is primarily used in German coal mines, where it excavates huge amounts of lignite, which is brown coal. These mega construction machines are more than just oversized equipment. They are built to handle the toughest jobs in mining, construction, and infrastructure projects around the world. Each one plays an important role in its respective industry, pushing the limits of what's possible in the world of heavy machinery. If you want to hear more stories of amusing projects, go ahead and like this video and subscribe to the channel, because we have got a lot more of this. Thanks for watching. Goodbye.